Hey yo, welcome everyone. A new video every day. This is Code Raw, and as usual, we're gonna solve some lead code problems for those who don't know about this channel. So basically, in this channel, I post a video. I go on stream every day where I solve some lead code problems. So we're grinding. Basically, we're grinding lead code problems every day till I find a job or internship. For those who likes lead code or programming in general, you can watch us. You can find me on GitHub, and you can find me on Instagram or LinkedIn. I'll be so happy if you follow me there. And without further ado, let's go. So yesterday we solved those two problems. If you don't know, we divide the videos or problems by themes. So yesterday we solved those two problems, which are routing oranges and float fill. And today we're gonna solve, or we're gonna try to solve, surrounded regions, where we secure our region surrounded by zombies, and word ladder, where to find the sequence of word to decode the anti-zombie cure. So welcome everyone. Hope you're doing okay. Bring something you can eat, bring something you can drink, and enjoy the video. So let's jump to the lead code. Let's erase this and that, and let's begin. So surrounded regions. Let's open a draw tab. Welcome everyone. Welcome stream man. So this is the problem of yesterday, and now we're starting a new one. So this problem is about a matrix which contains letters X and O, which capture regions that are surrounded. Connect. A cell is connected to adjacent cell horizontally or vertically. Region to form a region, connect every O cell. And surround the region is surrounded with X cells if you can connect the regions with X cells and none of the region cell are on the edge of the board. Okay. So a surrounded region is captured by replacing all O's with X's in the input matrix board. So let's jump to the example. So let's say we have this matrix. It's X, 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 O, O, X, 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 O, X, and X, O, X, X. I'm gonna make it look like this. The X's will be the same. We're gonna just replace the cell O's which are not in the board of the region. In the board of the region with X's. So here we're gonna replace X, X, and here X, and the rest is the same. X, 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 O, and X. So basically, it's like the problem of yesterday. We're gonna iterate through the whole matrix, and if we find a O, and besides the O there is another O, it can be from the 4 direction. We have to make those X's, and we cannot make this an X because it's on the board of the matrix. So we're gonna surround those by X's. It seems So today we should not waste a lot of time doing those problems. I'll try to make it in a 30-minute or 15-minute. So let's go. First, we're gonna begin to. There is no time. Okay, let's just make a while loop to iterate. No, we don't have to iterate through it. We don't have to iterate through it. So I'm gonna make a 2 for loops and I equals 0. Let's just define the rows and the columns. So rows equal board dot length and columns equal rows of 0 board of 0 dot length for int I is equal to rows and I plus plus. We're gonna need another for loop to iterate through the columns. Equal 0. G is lower than columns. G plus plus. Okay, so like that. So now we're gonna check if there is an O. We're gonna transform it to X, and it has to be in the middle of the matrix. It has to be not in the board. So how are we gonna do this condition? So let's suppose if there is a matrix like this. Let's change the color. If there is a matrix like this, can we transform those? I think not. Cannot be. Because it is the first is on the board and we cannot surround it. So every O has to be surrounded with more than 2. No. This is, and it's not in the border. There's 3, this is 2, this is 3, this is 3, and in the middle. I think we have to do another approach. We have to be quick. Let's try the first approach. So if board of E and G equal O and the hey, I think it's amazing what you're doing. Keep going with this kind of discipline. The world will become your. Thank you, man. Thank you. Welcome to stream. I'm on stream, by the way. So, if we find a node that is surrounded by, if we find a node and, okay, so this is the first condition, and the second condition that the O have to be not in the border of the matrix, which mean neither I or the G neither I of G or G have to be 0 or length or 0 on okay. So if I is different than 0 and I is different than rows minus 1, I think, or seems a little bit tricky, or G is different than 0 also, or G is different than columns. Now we're gonna transform every O to board of E and G equal X. So this is the first trial. I just want to see the result. Those. I just make quick test. Man. What? Variable rows class solution cannot find summable. من Java length x dot length. X dot length. Doesn't matter if it's a matrix of integer, of a character, of a... doesn't matter. Is there size? Okay, so size... It's already 30 minutes. Dot length. I don't know. Or because it is an array of char. Okay, so I'm gonna just test it on this, use this case, and then I'm gonna, so this is a 4x4 matrix. Just want to test this test case. Int, man, int. It's an integer. Good, great. Thank you, man. Welcome to stream. So this has to be right. So the test case. How did he transform this into? So this is 2 4, which means no 1 1 3. 1 3 G minus 1. No, just to be cool. Yeah. So 1 1 3. Print. Find island and exclude the ones with corner border. And maybe work your way from there. Find islands. I get it. Let's just so here we have 0 0 and then 0 1 2 3 0 1. Why did he stop here? Okay, it didn't stop. I don't know why this condition doesn't work. It is even working. He's not entering his condition, so operation binary operator, so it is it is one second. So I think now it has to work. What's your LC username? It's black me to someone. I'm gonna send it. Man, he's not entering the condition. If different of Z. Man, this condition is the whole problem, so I'm just gonna find the solution for this. So if E equals 0, or E or she. Okay, I'm gonna make a text case for this. If not if E doesn't equal which one and G doesn't equal 3. كذا. So x x x x x o o I equal 1, but g doesn't equal, but g doesn't equal 3, but g doesn't equal 3. What's up with this dude? أنا بروش أنا بكل غلط البروبلم. والله أنا الفيرة أخويا مرحبا فيك الصريح. أنا الفيرة من المغل ما شاء الله. So this one is 0 3. G equal 3. G equal 3, so if G is not 3, then not gonna make it. I think there is a mistake here. Not this. I think it's gonna work with this also. Test case it's always false, but the second is true, obvious. So it's not. Okay, I'm gonna switch it. So if this I think it's the same, but I'm just gonna try it. Same thing. Good luck, man. Give it up. You'll find something. Thank you, man. Welcome stream. Welcome stream, by the way. Man, 24 hours. 24 minutes. 24 minutes. It's a lot of time, actually, but do I have to change this? Do you try to advent of code? To advent? You mean to progress? Yeah, I think yeah. This condition. equal 0. Yeah, that's the case. I'm gonna make every condition individual. So let's just put it back, and then if in 0, then I'm gonna make this. Let's repeat that 4 times, which is a really bad code, but we don't have another solution for the moment, actually. So I'm just gonna try this logic. Man, this is unbelievable. I don't know what's the matter with it. I mean, there is an event called Advent of Code every year around Christmas, which has increasing challenging programming question every day, posts from December. No, actually, I didn't know about it. Thank you for telling me. I will search it. Advent of Code. Let's see it. Yeah, it seemed like a nice one. Oh. Why is the website not? Oh. Okay. Yeah, sure. I'm gonna check it. Thank you. You should try to do these first ones are easier for women, but get challenging. Okay, thank you, man. Just gonna check this. Just plot and just gonna check the condition if it's right. Implementation. No. I'm not gonna work with DFS. Man, I'm not gonna work with that. So it's about 30 minutes. I think it's time. I didn't even do one test case. This X has to be so I'm gonna make it from another one. I just check those elements. Let's say this, and that, or like this. If here I plus 1 equal length and I minus 1, no, it's the same thing. Cannot be. Let's check the topics. I think this problem is not that easy, so I'm just gonna try another solution with it. I just figure out on YouTube how I'm gonna do it. Now, what's his name? Like surrounding surrounding regions. Yeah, good job. Seems pretty odd. It sound working? Yeah, I think it is.
Manage everything and anything related to your work.
Hey everyone, welcome back, and let's write some more
So
new
not
code
hidden,
today.
I
So
think,
today let's solve the problem surrounded regions. This is a pretty interesting problem, and I think you're going to be really surprised. But let's continue next to the. There are many ways to solve this problem. I'm going to show you a slightly clever and easy way to solve this problem, but I think you can actually learn a lot from the type of solution I'm going to show you. It has to do with reversing the way you think about the problem. What I and some people like to call reverse thinking. So let's get into that solution right now. So up above you can see the example that we're trying to solve, this general problem we're trying to solve. But before we even get into that, let me just kind of ask you a simple question. Let's say I had a piece of paper like this one. Let's say I cut it like this, right? I have a small region over here called A. This is the A portion of the paper. And I have a other portion. This is the B portion of the paper. Let's say I want to keep only this portion. I only want to keep the A portion of the paper. So how can I ask for the A portion of the paper? Well, I can say only give me A, right? Only the A portion of the paper. That's the simple way to talk about it. But a more complicated and kind of a useless way to talk about it, in English at least, would be to say, give me everything in the paper except for B, right? Give me this entire paper except for B, right? Just cross B out. Just give me everything except for B. Why would you say that when you can just say, just give me A, right? Of course, that's the simple way to say it, but sometimes this reverse way of thinking can be helpful, especially in programming. I'm sure you guys already have kind of experienced that. So how is this going to be helpful in this problem? Let me explain. In the problem, they told us to capture the surrounding regions only, right? Only the surrounding regions. In other words, only this region that's surrounded. Another way, the opposite way of saying that, is capture everything except the unsurrounded regions, right? I basically restated the first bullet point with a longer sentence, right? Capture everything in this board except the unsurrounded regions, the regions that are not surrounded. In other words, capture the entire board except for this region, because this region is not surrounded. How do we know that this region is not surrounded? Is there an easy way to figure that out? Yes, it's very easy, because this region is connected to the border. Any region in the board connected to the border, right? There were some O's over here, some O's over here, here, or down here. We are not going to capture those. So this is where things are going to get a little bit clever. I wouldn't expect most people to be able to figure this part out, especially beginners. How are we going to actually implement this second bullet point? Basically, we're going to scan through every border cell, right? Everything on the outside. We're going to look for any O's. We found one O over here, right? So we found one region that's not surrounded, right? We know for sure this region is unsurrounded because it's connected to the border. Now we're going to run a DFS on this region because we don't want to capture it. How are we going to do that? Well, we're going to give it a temporary, basically a temporary value. We're going to change all the O's into T's. So I'm going to change this O into a T, right? Now, this O is not connected to anything, right? It could have been possible. Maybe there's another O over here, and it kind of forms this region that's connected to the border, right? And then we would change all of those into T's as well, right? But in this case, it's just a region of size 1, so that's all we do. Now, why are we changing?
I know pretty much about Python and automatization, but I didn't really work on that. So I really don't know about coding to Excel. I'm really sorry. Welcome stream, by the way.
to a temporary variable. Because, remember, we're trying to capture everything except unsurrounded regions. So now we marked this as an unsurrounded region, right? So now what are we going to do? We have this board. We're going to just do a double nested loop, iterate through every single row in this input grid, and anytime we see an O value, we're going to change it into an X, because now we know for sure that anytime we see an O, it's definitely part of a surrounded region, because any regions that were unsurrounded, we already changed them to a T.
That's fine. No
so
worries.
anytime we
Thank
see
you.
an
Welcome,
O,
stream,
we're
man.
going to change it to an X. So what I'm going to do is we see this is an X, leave it as it is, X, leave it. We see an O down here, change it to an X, change this to an X, this is already an X, etc. Change this to an X, and this is already an X. When we get to this T, we're going to ignore T's, right? We're only changing O's into X's, right? So that's the second phase of the algorithm. First we marked T's, now we're marking X's. Now the last thing we have to do, take a look at our board and take a look at the desired board that we want to return. What's the only difference? Basically, the unsurrounded regions, we change them to T's, but we still want them to be O's. So basically, again, we're going to do a double scan, a double for loop scan through the entire grid, right? Anytime we see a T, we're going to change it back into an O. So basically, this T over here would be changed, back into an O, and then we have the desired board that we want. And we can accomplish this. We're going to have to obviously iterate over the entire...
Yeah, okay, that's okay, but if there is a, like this, X, 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 and O, 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 and O. So this, like that. So those are the O's. I think it's connected to the border, so he cannot make this a T. And if he made a T, so he's gonna make those X's. But it's not surrounding, actually. It's not surrounding. Okay.
Entire board like 2 or 3 times or something. So the overall time complexity, let's say, is going to be n times m, where these are the dimensions of the board. But that is the entire time complexity.
We're gonna scan the borders of the matrix. So I'm gonna start with the line. For line E equals 0 and G equals 0. For E equals 0, and we have to make G equal 0. So I'm just assign if there is no better way to do it. So I'm gonna just iterate it through the lines and the columns.
Phase is gonna be to capture so E back the set or O is equal to the number of rows, which means it was too big, or column is equal to the number of columns, which means it also went out of bounds. And the other case is, remember, we're only capturing O's, so if the board at this position is not an O, then we can also return. So if board at row column is not equal to an O, then we can also return. So this has gotten to be a very long line. Let me shorten it up a little bit. So that is the main base case.
Right, our job's done. Because the array is empty, and it doesn't really give us any constraints. So that's our first step, first task. And then what we're going to do then is we're just going to define our row's length. Which
So I think it's obvious. We can just iterate through the border, or and find if there is O's. We're gonna transform it to T's or anything beside X, and then iterate through the matrix again and search for O's and make it X's. But the syntax is not working very well. So just convert to O's. We are sure this is not covered by X. Why? Because O can touch the boundary. This is what I meant. O can touch it. So if you make it a T and then just transform the others, it's not true. So we have to check the whole one. I think this is a... We found O. Stop task can be set as BFS or DFS. This point, same EG we own. Research I plus 1, I plus 2. Similarly, it's explained very well. Now we can mark these regions which are bad. Okay. And then just transform it to so O equal O, N equal rows and columns, Q equal to Q for in range port E0 equal if it's we're gonna iterate through the row. If it's equal O, then we're just gonna append its index and 0, and then for the last row we're gonna append it and the index of it. Okay, so then we're gonna just iterate. We iterate here in rows, and then we're gonna iterate through the columns. Same thing, and inbound return if it's inbound. So if I is lower than n, which is the number of rows, and g is lower than m, which is the number of columns, then it is true. Then it's gonna just return true. While q, so didn't understand that thing. Also, why it is in... He said it is in Java. So it's like a pseudocode, okay. So EG equal key pop left. But so yeah, obvious. Like the previous video. So he's gonna just check the borders. If he saw a connected O, then he's gonna make it another sample, and then iterate through it again. And for every sample he finds, he's gonna just make it an O. Seems very logic. And now we have to just... I think it's not the mood to solve hard one. I'm really tired. And by the way, I didn't sleep for a day, so my mind isn't processing very well. So I'm just gonna solve this. I hope we can solve it. It's about 44 minutes. It's too late actually, but we can. I think we can do it. So let's just make this for later. And now we have to solve those number of islands. God, make it easy. So we have a grid which represent a map of 1 and 0. So the 1 is land and 0 is water. Return the number of island. Here's our matrix. Ones and zeros. Let's say 3 by 3. Well, 3 by 3, just we have one island. Let's use his example. So 1, 1, 1, 1 and 0. 1, 1, 0, 1, 0. And 1, 1, 0, 0, 0, and 0, 0, 0, 0, 0. Okay, so 0 is water and 1 is land. So this is the land. This piece is the land. So the land can be in the border. How are we gonna count it? We have to count this as a one land. How are we gonna do it? And this is a 3 land. 1 1 0 0 0, and here you have 1, and here you have 1 1, and the rest is zeros. So we're gonna consider this as a this is island number 1, this is island number 2, and this is island number 3. Let's take good thinking of it. I think we can use a while loop, see if there is any adjacent land. If there is not, we're gonna increment a variable which is count by 1 and then break. So two while loop for I understand now. Man, the hype. I understand now. I'm just gonna not understand anything. So how can I do this? Can we, if we find a1, we're gonna search if it's adjacent by the 4 direction. But in any direction, we're gonna no, this is not. So we cannot count it like this. I want to check if they are not connected. So this one is not connected by those, and this is not connected. This one is not connected by the 4, so we can count it as 1. So we are looking for island, but he said, can we look for water? Look for water, and then if the water is not connected, so there's an island or more. And honestly, my brain is not working. It's not working. Honestly, I'm not processing very well. Today, it's tough day actually, and didn't sleep for a day, so... So excuse me, chat. Yeah, the example is clear, but how I'm gonna do it? Focus on networking also. Yeah, for sure. And for the record, this YouTube channel has helped me a lot through the network. Also, thank you very much for everyone who followed me on the channel, on LinkedIn or on GitHub. Really nice to meet you. You're all kind people. Thank you very much. And yeah, welcome stream, by the way. Welcome stream, man. How we're gonna do it? So it's about 52 minutes, and we didn't even find a solution for one problem. That's really depressing, man. But fuck it. I think the whole problem, or the whole lead code problems yesterday and today, it's about this DFS thing. And for the record, I don't understand any of it. So I'm gonna revise it here and now. So DFS, it's depth first search for graph similar traversal tree, like tree with traverse or adjacent verticals. Vertices 1 by 1 to reverse adjacent vertical, we completely finished traverse of vertical. This is similar to a tree with the first completely traverse left subtree and then move to the right subtree, and key difference that unlike trees graphs may contain cycle. To avoid processing a node multiple times, we use Boolean visit. So we have, it's not a matrix. 1 2 0 2 0 1 2 3. How's that possible? 0 1 3. Oh. So now visit 0 and put its adjacent node which not visited yet into the stack. So we're gonna put the adjacent of zeros in the stack who is not visited. So 3, 2 and 1. Visited is T. Smack hash map to it. Man, my brain is not processing it. I don't know even. Man, honestly, that's hard. I'm gonna just find an easy problem just to solve it because it didn't solve anything. So I'm gonna just pick a random easy one. So easy, longest common prefix. Remove together what's out there. I think that's easy. Remove element, find the index of the first occurrence in a string. So I think we can work on this. Let's try it. And if I don't solve it, then man, what's left? So given to arrays needle and high stack, return the index of the first occurrence of needle and high stack, or -1 if needle is not part of high stack. So high stack is this and needle is this. So we have to, needle is a part of high stack. So needle is a part. 0 and 6. The first occurrence at 0. So -1 because didn't occur. I think there is a. We're gonna iterate through. We're gonna search for the first. Character in needle. If it's in high stack. If it's, then we're gonna just compare the other ones. I'm gonna make those position in a list. I'm gonna just return the min of it. Okay, so let's do it. For int e equals 0. If needle of I equal a needle of 0 equal high stack of I. Then we have the same first letter. And then we're gonna iterate through the needle. For G int equals 0. G is lower than needle int length. G plus if we have to increment I also. We have to increment I. Or I plus G. I can make it I plus G. If needle of G equal high stack of I plus G, then I'm gonna append, what is this? I'm gonna append this position to a list. I'm gonna create here a list int position I think I can say at, so position dot add I, and then we have to sort it. Oh, it's already sorted. So I'm just gonna return the I think I can return actually the first time. It's gonna see it, just gonna return it. If needle of G equal high stack of Eve plus G for 3 times. So if it doesn't, I'm gonna just continue searching. Hey, welcome stream, man. How we're gonna do this? So it's about an hour. If needle equal okay, I'm just gonna add I and the first element, which will be sorted by the way, because it's here it's 0, and then here gonna return 0, and then here gonna return 1, and then 3, and then like 5 or 6, and this 0, the first element, is already sorted. So I'm just gonna add to this list, and after all this I'm just gonna return so after all this, if after all this so if it's here, I'm gonna return position of 1, and if it's not, he's gonna return return -1. This should be good. Yeah, I am a uni student. I'm currently in second year of software engineering. Welcome stream, by the way. So which uni though? In Tunisia, in my country, it's International Institute of Technology, in Sfax, especially. What's the problem? Welcome stream, by the way. I already mentioned is missing. Don't need an array dimension. Okay, I'm just gonna make it high stack of dot length. It's the max of it, actually. Okay, so let's just put it. Cannot iterate through a string like that. Through string Java. Welcome stream, man. I think it's time. Is it? Welcome everyone. Let's work for this. I think I find a way. I wish you best luck with this YouTube project. Thank you, man. Thank you very much. Welcome stream. So I think I found something. I'm just gonna modify it. So if high stack of length is lower than needle of length, actually it cannot be a substring of it, obviously. And for int, we're gonna iterate through those through the difference of it. If high stack proceed equal, just use equal, then we're gonna return I. Else we're gonna just return -1. So this is public and this and that. Yeah, that should be fine. Just submit it. So okay, like everyone else, it's okay. First one of the day. So I think here we can end our stream. It's about 1 hour 10 minutes. Thank you everyone for watching. Thank you for supporting the channel. Really so grateful for the help, for the support, for the comments. Thank you everyone, and see you tomorrow. Goodbye.